Yes, welcome once again to Maths Optional class. If you haven't watched the previous classes, then I would request you to go to the description and click on that link in the description. And after you click that description link, start watching from lecture number 2. Then you will understand everything clearly. Okay. So let's move on towards our next topic, which is skew Hermitian matrix. Okay. Skew Hermitian matrix. So skew Hermitian matrix, square matrix. Square matrix A equal to Aij, and this is a square matrix, so it will be it will have order of something like this: n cross n, means the order might be 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5, like that. Okay, so a square matrix means the number of rows is equal to the number of columns. Okay, is called skew Hermitian matrix, is called skew Hermitian matrix. If IFF means if and only if a conjugate is equal to your minus a. Okay, that is Aij. What is conjugate? I had told you in the previous lectures what is conjugate. You will first take the transpose, and then you will take the conjugate. Okay, so that is called as conjugate for all I comma j. This is comma, by the way. So a conjugate is equal to minus a, that is aij equal to minus aji for all I comma j. Now what does this mean? This will lead you towards transpose. Okay, ij and ji interchanging will lead you towards transpose. This conjugate will lead you towards conjugate, because this has led you towards transpose. Interchanging ij and ji has led you towards transpose, and this bar means conjugate, it will lead you towards conjugate. Bar will lead you towards the conjugate of transpose. Then again the minus sign will lead you towards skew Hermitian. Okay, the minus sign will lead you towards skew Hermitian. So in this way you can understand all these things. Okay, let me erase this. Yes. So, properties of skew Hermitian matrix. Now let us write the properties of skew Hermitian matrix. Properties of skew Hermitian matrix. Properties of skew Hermitian matrix. Property number 1. In case of skew Hermitian matrix, in the case of skew Hermitian matrix, all the diagonal elements are either 0 or purely imaginary. Okay. So in case of skew hermitian matrix, all the diagonal elements are either 0 or purely imaginary. What does this mean? Okay, means the diagonal element, suppose you have a matrix of this kind, 3 cross 3 matrix. Okay, you have suppose the 3 cross 3 matrix, and in order to be a skew hermitian matrix it must be what? Square matrix, already told in the definition. Okay, because over here in the definition of skew hermitian matrix we have written a square matrix. Okay, so it will be a square matrix. So in case of skew hermitian matrix, all the diagonal elements are either 0 or purely imaginary. Means the diagonal elements means these elements. Okay, these elements. So these elements are either 0 or they are purely imaginary. Purely imaginary means they will be only iota terms, iy. So a number is represented, in general a number is represented by x plus iy. So what is purely imaginary? Purely imaginary number means x is equal to 0. So only iy will exist in it. Only iy will exist in it. So in case of skew hermitian matrix, all the diagonal elements are either 0 or purely imaginary. So let us look at the proof of this. Let us look at the proof of this. Okay. Let A be a skew Hermitian matrix. Let A be any skew Hermitian matrix. Let A be any skew Hermitian matrix. Then Aij is equal to your minus Aji. Okay. So this is by the definition of skew Hermitian matrix. Now this will hold good. This is for all I comma j. Okay, this is for all I comma j. This will also, that implies that this will also hold good for diagonal elements. This will also hold good for diagonal elements. Okay, this expression which I have written over here, this expression, this expression will also hold good for diagonal elements, right? This will also hold good for diagonal elements. Okay, so that is for diagonal elements, that is I equal to j. Okay, so what will happen? Aii is equal to minus Aii conjugate. Okay, conjugate means minus Aii conjugate. So from here any number can be represented as x plus iy, and I had told you in the previous class, I had proved this, that whenever a number and its, for example, okay, for example I had proved this in the previous class, when the conjugate of a number is equal to minus of that number, then z is purely imaginary. I had proved this in the previous classes. Okay, purely imaginary. So by that condition, aii, what will be aii? That implies that aii is purely imaginary. But aii is the diagonal element. That implies that diagonal elements of a skew Hermitian matrix are either 0 or purely imaginary. So in case of 0 also this condition will be satisfied, right? In case of 0 also this condition will be satisfied, and in case of purely imaginary also this condition will be satisfied. So is purely imaginary or 0, you can write like that. Okay, so this is the thing. So this was the property number 1 of skew Hermitian matrix. This was what? Property number 1 of skew Hermitian matrix. Now we will move on towards the property number 2 of skew Hermitian matrix. What is the property number 2 of skew Hermitian matrix? In the case in the case of skew Hermitian matrix, in the case of skew Hermitian matrix, the sum or the sign of real part, the sign of real part above and below the principal diagonal are of opposite nature. Okay, so in case of skew Hermitian matrix, the sign of real part above and below the principal diagonal is of opposite nature. Let me show this to you. I am not going into the proof of this. You can prove it yourself. It is very easy to prove the way you have proved the previous things, but I am giving you just an example. Okay, the way you had proved the previous things, similarly you can prove this one also. Similarly you can prove this one also. So it is very easy to prove, and this is a common sense property. Okay, now above and below this principal diagonal, this is what? This is your principal diagonal. So all the elements, sign of real part. Okay, sign of real part, if you look, sign of real part are of opposite nature. Sign of real part are of opposite nature. Sign of real part are of opposite nature. Because it is very clear from this fact, because when you take the conjugate, okay, when you take the transpose and take the conjugate, when you take the transpose and take the conjugate, this particular part, after taking transpose and conjugate, means the transjugate, after taking the transjugate, this particular part will regain its sign. It will regain its sign. If it was plus I initially, then it will become plus I again, because after taking transpose you have taken the conjugate. But this particular part, even after taking the conjugate, its sign won't change, this particular part. Okay, so this particular part will become opposite in sign, because it is real part, so its conjugate will also be the same number. So this is a common sense property, that in the case of skew Hermitian matrix, the sign of real part above and below the principal diagonal are of opposite nature. This is a very much common sense property. Okay, now property number 3, again we won't go into the proof of it. So property number 3, what does it suggest? A skew Hermitian matrix, a skew Hermitian matrix over the field of real number is nothing but a real skew symmetric matrix. Okay, so a skew hermitian matrix over the field of real number is nothing but a real skew symmetric matrix. Now let me prove this to you. Okay, let me prove this to you. So in this case, okay, in this particular case, let us suppose that I have taken real field. So in the field of real number, all these elements, that is the iota elements, will go away. So iota elements will go away. 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 Okay. So I am not this is not related, but I am just telling you. Okay. So the iota elements will go away. Iota elements will go away, and LMN, LMN. So what does this become? This clearly became your what? Real skew symmetric matrix, because you took all the elements to be real. Okay, so it became a real skew symmetric matrix. So a skew hermitian matrix over the field of real number, that simply means that all the imaginary parts become zero and only the real part remain. So a skew hermitian matrix over the field of real number is nothing but a real skew symmetric matrix. Okay. So a skew hermitian matrix over the field of real number is nothing but a real skew symmetric matrix. This property also you will have to remember. Now the fourth property, the proof of which I won't tell you. If A be any skew hermitian matrix, if A be any skew hermitian if A be any skew hermitian matrix, then Ka is also skew hermitian matrix for some real scalar k, for some real scalar k. Okay, so if A is any skew hermitian matrix, if A is any skew hermitian matrix, then Ka is also skew hermitian matrix for some real scalar k. Now what does this mean? Suppose A is any skew hermitian matrix, then what will happen is that for any real scalar k means 2a, 3a, 2.5a, all these will also be your uh, skew hermitian matrix. You can easily prove this. Okay, you can easily prove this by taking suppose this is your, so A conjugate will be equal to your minus A. Why? Because A is, so let us prove this. It is very easy to prove. A conjugate will be equal to minus S. Then you will take Ka conjugate. If it comes out to be equal to minus K, then what will happen? So K conjugate A conjugate. Now you know this very well, that this quantity will be equal to k only, right? So because it is a real scalar, and A conjugate will be equal to minus A, right? So what does this become? This becomes minus Ka. So as it becomes minus Ka, so this also satisfied the skew Hermitian matrix property, right? So it is very easy to prove. That's why I am not proving these properties. Okay, the properties which are coming right now. If A and B, if A and B be two skew Hermitian matrices, let A and B be two skew Hermitian matrices of the same order, then K1A plus minus K2B is also skew Hermitian matrix where K1 and K2 are real scalars. So K1 and K2 are real scalars, and A and B are two skew Hermitian matrices, and they are of the same order. Then K1A plus K2B is also a skew Hermitian matrix, provided K1 and K2 are real scalars. Okay, this is important. If they are complex scalars, then this will not hold good. K1 and K2 are real scalars, then that's why this property holds good. Okay. So if A and B are two skew Hermitian matrices of same order, this is also very important. Same order is also very important. If this is 3 cross 3, then this should also be 3 cross 3. Okay. If suppose A is your 3 cross 3, then B should also be 3 cross 3. Okay. So this is the property which is proved, which can be proved very easily. I mean, sixth property: if A and B be two skew Hermitian matrices, if A and B, if A and B be two skew Hermitian matrices, okay, be two skew Hermitian matrices of same order, then AB is skew Hermitian matrix if AB is equal to B. If A and B are two skew Hermitian matrices of same order, then AB is a skew Hermitian matrix if AB is equal to BA, that is A and B commute. Okay. If AB is equal to BA means A and B, if they commute, then these two skew Hermitian matrices of same order will yield you the product will be skew Hermitian. Okay. This also you can prove very easily, so I won't go into the proof of that. Then seventh one: if A B, if A and B be two hermitian matrices of same order, then AB minus BA is skew hermitian matrix. So this is also self-explanatory, and you can prove it yourself based on the based on all those things which we have already proved earlier. You can easily prove this also. If A be any square, if A be any square matrix, then A minus A conjugate is skew hermitian matrix. Okay. Then ninth property, all positive odd integral powers of skew hermitian matrices are skew hermitian, whereas all positive even integral powers of skew hermitian matrices are hermitian. So let me tell you, all positive odd integral powers. Positive odd integral powers mean 1, 3, 5, 7, 9, 11, like that. So positive odd integral powers are like that. So if we take the positive odd integral power of skew hermitian matrices, okay, suppose A is equal to your skew hermitian matrix, skew hermitian matrix, then what will happen? A to the power 1, A to the power 3, A to the power 5, A to the power 7, A to the power 9, A to the power 11. These are what? Etc. These are what? Skew hermitian. And positive even integral powers like A square, A to the power 4, A to the power 6, A to the power 8, A to the power 10, A to the power 12, all this will be basically your hermitian. Okay. So this is the thing. Now note, write a note. So note number 1. Every square matrix can be uniquely expressed as the sum of hermitian and skew hermitian matrices. So every square matrix can be uniquely represented as the sum of hermitian and skew hermitian matrices. So let us write the proof over here. Okay, let us write the proof over here. Proof: let A be any square matrix. Let A be any square matrix. So therefore, what is there? Half A plus A conjugate, okay, plus half A minus A conjugate, right? So this is your Hermitian matrix. This is your Hermitian matrix. And this is your what? Skew Hermitian matrix. This is your what? This is your skew. In case of Hermitian, okay, you have proved the similar situations in the previous lectures. So you can do it yourself. Okay, you can do it yourself. So first you will prove the existence. You will prove first the existence, then you will prove the uniqueness. You have already done this. Okay, now note number 2. Note number 2: if A is Hermitian matrix, if A is Hermitian matrix, then iota A is skew Hermitian matrix. So if A is Hermitian matrix, then iota A is your skew Hermitian matrix. Okay. So let's do the proof of this. Let's do the proof of this. Let A be Hermitian matrix. Then what will happen? Clearly your A conjugate will be equal to A. because A is Hermitian. So then IA conjugate, okay, IA conjugate will be equal to your I conjugate A conjugate, which is equal to your minus I A, okay, by this equation number 1, by 1. That implies that your IA is skew Hermitian because conjugate of IA is minus I. So IA is skew Hermitian matrix. Now number 3, if A is skew Hermitian matrix, then IA is Hermitian matrix. Then IA is Hermitian. Okay. If A is your skew Hermitian matrix, then IA is your Hermitian matrix. So the proof of this is over here. Let A be skew Hermitian matrix. Then what will happen? Therefore, as it is skew Hermitian, so A conjugate will be equal to minus A. Now we have to prove that I is Hermitian, right? So we will take again the conjugate only. So as soon as we take the conjugate, we get something of this kind. Then what we will get? Conjugate of I will be minus I, and A conjugate will be equal to minus A. So minus into minus will become plus, so it will be plus IA. Okay, so as IA conjugate has come out to be equal to IA itself, so this is clearly a property of Hermitian matrix. So IA is your Hermitian matrix. So IA is your Hermitian matrix. Then the note number 4. Okay, then the note number 4. B conjugate AB, B conjugate AB is Hermitian or skew Hermitian matrix according as A is Hermitian or skew Hermitian. Okay, so B conjugate AB is your Hermitian or skew Hermitian, depending on whether A is Hermitian or skew Hermitian matrix. So if your A is Hermitian, if your A is Hermitian, then B conjugate AB will also be Hermitian. And if your A is suppose skew Hermitian, then your B conjugate AB will also be skew hermitian. Okay, so this is the thing. So let us write the proof of this. The proof B conjugate AB, again its conjugate, will be equal to your B conjugate A conjugate B conjugate. Okay, so it will be equal to your B conjugate A conjugate B, right? Now clearly from here two conditions arise. B conjugate A B, if A conjugate is equal to your A, and it will be equal to minus B conjugate AB if A conjugate is equal to your minus A. Okay, this is very clear. So clearly from here, if this condition is for skew hermitian and this condition is for hermitian. So if A is hermitian, then this is also hermitian because it has come out to be the same. And if A is skew hermitian, then this is also skew hermitian because it has come out to be the minus sign. Okay. So we can write hence hence B conjugate AB is hermitian or skew hermitian matrix according as A is hermitian or skew hermitian matrix or skew according as A is hermitian or skew hermitian matrix. So B conjugate AB is hermitian or skew hermitian matrix according as A is hermitian or skew hermitian matrix. Okay. Now the fifth property we will do in the next class. Okay. Fifth property onwards we will do in the means the note number 5. Note number 5 onwards we will do in the next class. So see you then. Thank you very much. Jai Hind, Jai Bharat. And if you haven't watched the previous classes, then you should watch them so that you get the full benefit of this class. Thank you very much.